Hi, this is a quick preview of precision landing for ArduCopter. Explaining really quick what's going on with the screen. In the upper left we have terminal running and showing the current status of the precision land Python script running. Here we've got a map right in the center and our console, which will give us, it's like a dashboard, which will give us our altitude, ground speed, and kind of the current status of the vehicle. And the most important part in the upper right is a simulated view of a camera, and this camera would be facing down towards the ground if it were on a copter. Brown is supposed to simulate the ground, and right here we have a bullseye target. As you can see, the algorithm is currently picking up the target with the green rings to signify the algorithm is meant to pick up the rings, so the valid rings that it's detecting. Currently I'm hovering above the target in the ArduCopter simulator at 7 meters or 6 meters. So I'm going to take it up to 20 meters and then stick it into guided mode, which should start the landing and hopefully successfully land it onto the target. So we're up at 15 meters right now, 20 meters, flick it into guided mode, and if you look in the upper left you can see what the program is actually detecting. So when it detects the target, it will try to move towards the target, and if you can read what the terminal is saying, it's saying how far away it thinks the target is, and it's responding accordingly. You'll see the target twitch around in the simulator, and that's because the camera will be hard mounted to the copter in real life. So if you roll to the left or roll to the right, it will shift the image. So that's just being simulated. As you can see, we're about 0.02 meters away, so we're pretty on target. We're descending at a rate of, I think, half a meter a second. 2 meters to go, 1 meter, and at 1 meter we enter final descent, so it just lowers with no longer using vision tracking. And currently you're seeing the screen, the target go in and out. That's just how I wrote the camera simulator. When it goes to -1 or 0 altitude, it kind of gets a bit sloppy. So you're just seeing the target bounce around as a floating point error. But that was the precision land working. I'm actually going to run a quick test, bring it back up, put it into loiter mode, bring it from the target. So as you saw in that example, it landed pretty dead on in the target. The targeting said it was 0.05 meters away from the center of the target. I'm going to put it into RTL, and this target is actually stationed at the home location, and we'll see that RTL will be nowhere near as close to this precision land. And RTL works strictly off GPS, and this algorithm, this precision land algorithm, is working strictly on vision. So let's run RTL really quick and see where it puts the vehicle. So I just put it in RTL mode. It's going to bring it above the target and then start descending. We can already see that it will miss the target, probably by a couple meters. 8 meters, and it's already to the right. 6 meters, still to the right. 4 meters. 3 meters to go. And 1 meter down, it's still to the right. So it missed the target, which would be a failed land in when you're trying to get a very precise landing location. This is a simulator. I'm guessing GPS error or lack of precision is incorporated into the simulator. In previous tests I've had it seem off as much as 7 meters away from the target. In real life, depending on your GPS accuracy at the current moment, you could be off up to 10 meters. So this precision land program uses vision and hopes to reduce that error and get dead on to the location you'd like to land at. Thanks for watching the video.